Hey everyone, Sankalp Kaushik here. I hope you all are well and I'm delighted to have you. This is the final video of the assignment given by Skyfi Labs under the course Structural and Foundation Analysis. In this video, we will be doing a project on foundation design of a building. First, let's understand the problem statement. We are going to design a mat footing. The building that we have to design a mat footing is the same G+23 building which we have discussed in our earlier video. So here are 16 columns in total which are arranged 6 meter apart in both X and Y direction. The column names C1, C2, C3, etc. are shown up to C16 as shown. Let's consider a safe bearing capacity of soil as 300 kN per meter square and an allowable settlement of 1 cm. The column dimensions and the dead and live load on the columns are taken from the previous video as shown, as it's the same building. These are the column name, the dimensions, the dead load, live load, and the materials. Here are the remaining columns details. Now calculating the subgrid modulus. As we know, we have taken soil bearing capacity of the soil as 300 kN per meter square and an allowable settlement of 1 cm. So our subgrid modulus comes out to be 3 into 10 raised to the power 4 kN per meter cube. The base slab of the building is 18 meter in both X and Y direction. So considering 18 meter length in both, the design strip width is 4.5 meter. Now let's take it as 4 meter. This is the plan of the building. The mat footing underneath will be extended on all sides to cover the corner columns. Let us design a footing which is extended 2 meter on all sides of the building plan. Then the actual length and breadth of the mat footing will be 22 meters instead of 18 meter. Now let's open the saved software. Select new model. Use built-in setting and change the properties as shown here. Then click on OK. The building slab is of 18 into 18 meter dimension. So we will draw the building slab of 18 into 18 meter dimensions with the grid. So let's use 19 number of grids in both X and Y direction. And spacing as 1 meter in both direction. And select grid only option, then click on OK. The grid of 18 into 18 meter dimension has been formed. Now we will define the required property. So go to define, then click on material properties, and then add M40 concrete and HYSD 500 rebar as shown. Now add the HYSD 500 steel. Now we will define the elements with these materials. So go to define, then in section properties, go to slab section. Click on add new property. Write it as mat footing. Change the slab material to M40. Modeling type as shell thick. Type as matte. And let's say thickness as 500 mm initially. And then click on OK. The footing property has been defined. Now we will define the column properties. As we know, there are 16 columns and there are only two different types. So let's first add one column of M40 material and dimension 500 into 500 mm. And add another column of 600 into 600 mm dimension. And click on OK. Now we have to define the soil subgrade properties. So go to define menu, click on spring properties and then click on area springs. Here add new property. Let's name it as soil 1. Change the subgrade modulus as 3 into 10 raised to the power 4 as we have done previous. And then click on OK. Click on OK once again. Now define load combinations. Go to define menu and then go to load combinations. We will define two load combination, one for ultimate load and one for service load. Click on add new combo. Let the combo name as combo 1. Then change the scale factor to 1.5. Add another. Change the load name as live and scale factor as 1.5. Click on OK. Now add another combo of for service load. Let it be comb 2. Now add, change the load name as live. Then click on OK. Click OK on once again. All the required properties have been defined. We will now proceed with the drawing of elements. So go to the draw menu and select floor wall object and then select draw floor wall option. Check that mat footing property is selected. Now start by clicking one corner of the grid system and click on the other corner 18 meter apart one by one. Then go back and click on the first point to close the figure. Press escape on the keyboard to exit. This is the slab of the building plan dimension. We will now extend the slab by 2 meters on all sides. Click once inside the area of the footing to select it. Click on edit option, then click on edit shell option, then click on expand shrink shell option and enter the value of 2 meter, that is 2000 mm. Then click on OK. Now we will place the columns on the footing. So go to draw menu and select draw beam column brace object and then click on quick draw columns. Change the property below to none. And the property above to column 500 into 500. Change the height below to 0 and height above to 2 meters, that is 2000 mm. Now the column 500 into 500 property is selected and it will be set for all the columns except columns C6, C7, C10 and C11 as it has dimensions of 600 by 600. So place this column in all the position except these four. Now we have assigned the column 500 by 500. Now we will change the property to column 600 into 600. And then place the four columns C6, C7, C10 and C11 in the similar fashion. Press escape after we have completed drawing all the columns. We can also see this in 3D view. Here we can see that all the columns are defined at their correct position. For better view, click on use extruded view for frame objects and then use extruded view for shell objects. Here comes the proper view. The matte footing and above which the columns are shown. Now coming to the plan view. We will draw the design strip on the footings. So go to the draw menu and select draw design strip. Change the design strip width to 4 meters. For the strip layer A, Draw the 4 design strip in the X direction through the column centers as shown. Right click outside after drawing each strip to discontinue the strip. After drawing the design strip layers A, change the layer to B. And again draw the 4 design strip in the Y direction. Press escape after completion. Now we will assign the properties and loads to the footing. Click on footing area to select it. Once selected, go to the assign menu, select shell loads, select shell, and then click on area springs, select soil 1, apply, and then click on OK. The soil properties beneath the footing has been assigned. Now we will assign the loads on the column centers. Here the loads at each of the 16 points are different, so we cannot select the points together. Select the first point for a column, go to assign, then click on joint loads and then force. Change the load pattern name as dead, and the value of the dead load can be taken from the table, that is 1850 kilonewton in the negative z direction. So enter negative sign of 1850. Change the size for load for punching shear to 500 mm by 500 mm. Click on OK, and the dead load is assigned to C1. Again select the point C1 and go to assign menu, then joint loads, then force. This time change the load pattern type to live and change the load value, that is we can take it from the table, that is 797.6 kilonewton. So change the value to 797.6 kilonewton and then click on OK. In this way, we will have to design the different loads in all the columns one by one. First, assign the loads in the columns having 500 by 500 mm dimensions. Similarly, apply the remaining loads on the columns having dimensions 600 mm into 600 mm. Select the C6 point and assign the load of 5414.9 kN as shown in the table. And change the dimensions to 600 mm by 600 mm. Click on OK. Now apply the live load and the remaining loads on the other three columns. Now we have applied all the loads on each of the columns. Press Escape. Now right click on the design strip one by one and change the rebar material to HYSD 500. Change the material to HYSD 500. In this way, assign the rebar material to the 4 design strips in the X direction and the 4 design strips in the Y direction. Now we will run analysis on the model. Go to analyze and then click on run analysis option. Save the file with a suitable name. And wait for the analysis to complete. Once analysis is complete, the displacement values of the different slab regions are displayed. Now, go to Analyze menu again and then click on Run Analysis and Design option. After that, go to the Display menu and then click on Show Punching Shear Design. In punching shear ratio, in most of the point have the value greater than 1, which does not satisfy the criteria. So unlock the model and increase the depth of the slab to let's say 1200 mm this time. Let's increase it to 1200 mm this time. Then click on Analyze and click on Run Analysis and Design option. Click on Display option and check the punching shear values. Here we can see that all the values are less than 1 this time. So this is the final design of the footing under which the design check has passed. Here are various options like reports, summary report, project reports can be downloaded from here. That's all for today. Thank you so much.